Right now, as you're watching this video, something extraordinary is happening in the darkness past Mars. An object that shouldn't exist according to everything we thought we knew about our cosmic neighborhood is racing toward the inner solar system at speeds that defy comprehension. But here's what should make your blood run cold. It might not be traveling alone. Tonight, we're diving into one of the most unsettling discoveries in modern astronomy. A mystery that's forcing scientists to question whether we're witnessing nature's chaos or something far more deliberate, something that could rewrite our understanding of what lurks in the vast emptiness between the stars. Before we venture into this cosmic story together, I'd love to know where you're tuning in from tonight. And if you find yourself drawn to these existential puzzles that challenge everything we think we know, I'd be grateful if you gave this video a like and perhaps subscribe to join our community of cosmic truth seekers. Get ready. The journey begins now. This is the tale of 3I Atlas, and by the time we're finished tonight, you'll understand why some of the world's brightest minds are losing sleep over what this interstellar visitor might represent, not just for our understanding of the cosmos, but for the very survival of everything we hold dear. Picture the scene at the Asteroid Terrestrial Impact Last Alert System facility in Chile on July 1st, 2025. It's another routine night of scanning the heavens, searching for potentially hazardous asteroids that might threaten Earth. The massive telescope array sweeps across the sky with mechanical precision, its digital eyes capturing thousands of images each night. But on this particular evening, something appears in the data that makes astronomers stop dead in their tracks. There, moving against the background of distant stars, is an object that shouldn't exist. Not just another space rock tumbling through our solar system, but something far more profound. Something that has travelled across the vast gulf between stars, carrying with it secrets from realms we've never seen. 3I Atlas, as it would come to be known, represents only the third confirmed interstellar object ever detected passing through our solar system. The 3I designation marks it as the third of its kind, following the enigmatic Oumuamua in 2017 and the more conventional comet 2I Borisov in 2019. But from the moment of its discovery, 3I Atlas began defying every expectation astronomers had developed about these cosmic wanderers. The numbers alone should make you pause in wonder and terror. This ancient traveller is hurtling through space at 58 kilometers per second relative to our Sun. That's over 130,000 miles per hour. To put this in perspective, if you could drive a car at that speed, you could circle the Earth in less than 12 minutes. But 3I Atlas has been maintaining this incredible velocity not for minutes or hours, but for billions of years, drifting through the cold emptiness between stars since before our solar system even began to form. When astronomers first calculated its trajectory, they expected to find the typical characteristics of an interstellar visitor. A small dark object, perhaps a few hundred meters across, following a hyperbolic path that would carry it quickly through our neighborhood before disappearing back into the cosmic void. What they discovered instead has shattered every assumption about what these ancient wanderers should look like. 3I Atlas is massive, unimaginably massive. Recent observations from the International Gemini Observatory have revealed an object weighing more than 33 billion tons, stretching across at least 3 miles of space. Some estimates suggest it could be even larger, potentially reaching 3.5 miles in diameter. To understand the scale of this cosmic behemoth, imagine an object larger than Mount Everest, racing through space at speeds that make our fastest spacecraft look like they're standing still. But here's where the story takes a turn into truly unsettling territory. The sheer size of 3I Atlas creates what scientists are calling a major statistical anomaly. According to our understanding of how interstellar objects should be distributed, we should have discovered hundreds of thousands of smaller visitors before encountering something of this magnitude. The mathematical models that govern planetary formation and ejection processes predict a universe filled with tiny fragments of rock and ice, with massive objects, like 3I Atlas, being extraordinarily rare. Yet here it is, the third interstellar object we've ever found, and it dwarfs its predecessors by 3 to 5 orders of magnitude. It's as if you went fishing in a lake and caught 3 fish, only to discover that the third one weighed more than 1,000 times what the first 2 combined. The implications are staggering and deeply troubling. Harvard astronomer Avi Loeb, never one to shy away from controversial theories, has pointed out that this size discrepancy suggests something fundamentally wrong with our understanding of what's out there in interstellar space. The universe, according to our models, should be teeming with small debris from planetary formation processes. The fact that we've found something so massive so quickly either means our models are catastrophically incorrect, or 3IA-TLAS represents something entirely different from natural cosmic debris. But the size isn't the only thing that's keeping astronomers awake at night, as powerful telescopes around the world have trained their eyes on this mysterious visitor. They've begun detecting something that wasn't supposed to be there, something that transforms this already extraordinary discovery into a potential crisis of cosmic proportions. The first hints came from the Hubble Space Telescope's detailed observations in August 2025. Instead of the clean, solitary profile expected of an interstellar comet, Hubble revealed something far more complex. The images showed what appeared to be a teardrop-shaped cocoon of dust and gas surrounding the main object. But embedded within this coma were structures that didn't match any known cometary behavior. Follow-up observations from ground-based telescopes began revealing even more disturbing details. The spectroscopic signatures suggested not one massive object, but multiple distinct sources of reflected light moving in formation. The polarimetric data from the Very Large Telescope showed asymmetries that couldn't be explained by a single nucleus undergoing normal outgassing processes. Then came the observations that changed everything. Dr. Sarah Chen, a planetary scientist at the European Southern Observatory, was analysing high-resolution images from the Atacama Large Millimeter Array when she noticed something that made her call an emergency meeting with her colleagues. Within the expanding coma of 3I Atlas, she had identified at least 7 distinct point sources, each showing independent motion relative to the main body. At first we thought it might be fragmentation, Dr. Chen explained to her stunned team. Comets break apart all the time as they approach the Sun, but the trajectories don't match any fragmentation pattern we've ever observed. These objects are maintaining coordinated motion. They're not drifting apart randomly like debris should. They're staying together, as if they're deliberately maintaining formation. The implications hit the astronomical community like a shockwave. If Dr. Chen's observations were correct, 3I Atlas wasn't a single interstellar object at all, but rather a collection of objects moving together through space. A swarm of cosmic entities that had somehow maintained their formation across billions of years and countless light years of interstellar travel. The natural explanations came quickly, as they always do when faced with observations that challenge our understanding. Perhaps 3I Atlas was a loosely bound rubble pile, held together by weak gravitational forces. Many asteroids in our own solar system exist as collections of smaller fragments that orbit around their common center of mass. Maybe we were witnessing the gradual dissolution of such a structure as it encountered the increasing heat and radiation of our Sun. Another possibility involved the complex dynamics of how objects are ejected from their home star systems. Computer simulations show that when giant planets migrate inward during the early stages of planetary system formation, they can fling entire families of objects into interstellar space simultaneously. These ejection events could potentially launch groups of objects along similar trajectories, creating the appearance of coordinated motion even across vast distances and timescales. The gravitational effects of our own solar system might also play a role. As 3I Atlas penetrates deeper into the Sun's gravitational influence, tidal forces could be stretching and deforming what was once a single coherent object. The differential gravitational pull on various parts of the structure might be revealing internal components that had remained hidden during its long interstellar journey. Yet none of these natural explanations fully account for what astronomers are observing. The precision of the formation, the apparent coordination of movement, and the sheer scale of the structure all point towards something more organized than random cosmic debris. This is where the conversation takes a darker turn, venturing into territory that makes many scientists deeply uncomfortable. Because if natural processes can't fully explain what we're seeing, we're forced to consider alternatives that challenge our most fundamental assumptions about our place in the universe. The possibility that 3I Atlas might represent some form of artificial construct has been raised by several prominent researchers, though always with careful caveats about the extraordinary nature of such a claim. The idea isn't entirely without precedent in scientific speculation. For decades, researchers have theorized about how advanced civilizations might explore the galaxy using self-replicating probes or coordinated swarms of smaller vehicles. The concept of a probe swarm offers certain advantages over single large spacecraft for interstellar exploration. Redundancy protects against the failure of individual components during journeys that span millions of years. Distributed sensors can gather more comprehensive data about target systems, and the ability to deploy multiple specialized units allows for more flexible mission architectures than any single probe could provide. If an advanced civilization wanted to study our solar system, they might indeed send something that looks remarkably similar to what we're observing with 3I Atlas. A collection of coordinated objects, each perhaps serving different functions, maintaining formation across interstellar distances while appearing to casual observation like natural cometary debris. The timing of such a visit would be particularly significant. Human civilization has been broadcasting radio signals into space for over a century, creating an expanding sphere of electromagnetic radiation that now extends more than 100 light-years from Earth. Any sufficiently advanced civilization within that radius would know of our existence and might be curious enough to investigate. This possibility forces us to confront some of the most profound questions in all of science. Are we alone in the universe? If we're not alone, why haven't we detected clear evidence of extraterrestrial intelligence? The Fermi paradox, named after physicist Enrico Fermi, captures this puzzle perfectly. With billions of stars in our galaxy and countless opportunities for life to arise and evolve, the universe should be teeming with civilizations. So where is everybody? One of the most chilling answers to Fermi's question is the dark forest hypothesis, popularized by science fiction author Liu Cixin, but taken seriously by many researchers. This theory suggests that the universe is filled with civilizations, but they remain hidden because revealing your location is tantamount to signing your own death warrant. In a cosmos where resources are finite and the intentions of others are unknowable, the safest strategy is to remain silent and eliminate potential threats before they can eliminate you. Under this scenario, the arrival of 3I Atlas could represent something far more sinister than scientific curiosity. If we are indeed witnessing a probe swarm from an advanced civilization, their intentions might not be benevolent. They could be conducting reconnaissance in preparation for something we'd rather not contemplate. The orbital dynamics of 3I Atlas add another layer of concern to this already troubling picture. Unlike the previous interstellar visitors, which followed trajectories that carried them quickly through our solar system, 3I Atlas is following a path that brings it uncomfortably close to the inner planets. Its closest approach to the Sun will occur in late October 2025, at a distance that places it just inside the orbit of Mars. But it's what happens after perihelion that has planetary defense experts paying close attention. Computer models show that 3I Atlas will pass within 30 million kilometers of Mars in early October, close enough that any debris or secondary objects could potentially interact with the red planet's gravitational field. While 30 million kilometers might seem like a safe distance, in astronomical terms, it represents an uncomfortably close encounter. More troubling still is the possibility that the swarm might deploy additional objects as it passes through the inner solar system. If 3I Atlas is indeed artificial in nature, its components could separate and take up independent orbits around our Sun, creating a permanent presence in our cosmic neighborhood. The implications for planetary security would be profound, fundamentally altering the strategic landscape, not just for Earth, but for any future human expansion into the solar system. The response from the global astronomical community has been unprecedented. NASA has mobilized an array of space-based assets to monitor 3I Atlas, including the Hubble Space Telescope, the James Webb Space Telescope, and a host of planetary missions. The European Space Agency has redirected several of its Mars orbiters to observe the object during its close approach to the red planet. Even amateur astronomers around the world have joined the effort, contributing observations and data analysis to help unravel the mystery. The James Webb Space Telescope has already provided crucial insights into the composition of 3I Atlas, revealing a complex mixture of water ice, carbon dioxide, carbon monoxide, and various organic compounds. These chemical signatures are consistent with what we'd expect from a natural comet, but they don't rule out more exotic possibilities. An artificial probe might well be designed to mimic the appearance of natural objects, using real cometary materials as camouflage or as reaction mass for propulsion systems. Perhaps most intriguingly, Webb has detected the presence of hydrogen cyanide in the object's coma, with production rates that have been steadily increasing as it approaches the Sun. On Earth, hydrogen cyanide is primarily associated with industrial processes and certain biological systems. Its detection in an interstellar object raises questions about the chemical processes occurring within 3I Atlas and whether they might be more complex than simple sublimation of ancient ices. The polarimetric observations have revealed another puzzle. The way light reflects from 3I Atlas's coma shows characteristics that don't match any known solar system comet. The particles in the coma exhibit an unusually high degree of negative polarization, suggesting dust grains with properties unlike anything in our experience. This could indicate formation processes in the object's home star system that operated under different conditions than those that shaped our own solar system, or it could suggest something more artificial in nature. As October approaches and 3I Atlas draws closer to its solar encounter, the mystery continues to deepen. The object has begun brightening more rapidly than predicted, suggesting increasing activity as solar heating penetrates deeper into its structure. But the pattern of this brightening doesn't follow the smooth curve expected from normal cometary outgassing. Instead, it shows irregular variations that could indicate complex internal processes or even deliberate modulation of output. The next few months will be crucial for unraveling the true nature of this cosmic visitor. Advanced telescopes around the world are preparing for intensive observation campaigns during and after perihelion. The data collected during this period could finally provide definitive answers about whether we're dealing with natural phenomena or something far more extraordinary. But as 3I Atlas continues its approach, racing toward the inner solar system at speeds that compress millions of years of cosmic evolution into mere months of human observation, we're left to confront a fundamental question that strikes at the heart of our existence. Are we witnessing the first clear evidence that we are not alone in the universe? Or are we simply seeing nature's capacity for creating phenomena so strange and complex that they challenge the very limits of human understanding? The answer may determine not just our place in the cosmic order, but our future as a species capable of surviving in a universe that might be far more crowded and dangerous than we ever dared imagine. As the mysterious swarm continues its relentless approach, we can only watch and wonder what other secrets might be hiding in the shadow of 3i Atlas, racing toward us through the darkness between the stars. The scientific community's attempts to maintain calm professionalism began cracking under the weight of accumulating evidence that defied every natural explanation they could muster. Dr. Elena Vasquez, director of the Deep Space Surveillance Network, found herself staring at data streams that seemed to mock decades of carefully constructed theories about how the universe should behave. "Look at this trajectory analysis," she whispered to her colleague during a late-night session in September 2025. "The secondary objects aren't just maintaining formation, they're adjusting their positions relative to each other. That's not how debris behaves. That's not how anything natural behaves." The comparison to our previous interstellar visitors makes the anomaly even more stark. When Oumuamua tumbled through our solar system in 2017, it presented its own mysteries. The cigar-shaped object exhibited non-gravitational acceleration that couldn't be explained by normal outgassing, leading to wild speculation about its true nature. But Oumuamua was solitary, silent, and quickly disappeared back into the cosmic void before we could study it properly. 2i Borisov, discovered in 2019, proved more conventional. It behaved exactly as a natural interstellar comet should behave, outgassing water vapor and showing all the expected characteristics of a chunk of ancient ice and rock from another star system. Astronomers breathed a collective sigh of relief. The universe was making sense again. But 3i Atlas has shattered that comfortable return to normalcy. Where Oumuamua was roughly 400 meters long and 2i Borisov stretched perhaps 2 kilometers across, 3i Atlas dwarfs them both. More troubling still is the growing evidence that it represents not one object, but many, coordinated in ways that stretch the boundaries of natural explanation. The latest observations from the Atacama Large Millimeter Array have revealed structure within structure, like Russian nesting dolls of cosmic proportions. Within the primary coma surrounding the main body, at least 7 distinct emission sources maintain precise spacing relative to each other. As the entire formation approaches the Sun, these components have begun exhibiting behaviors that no natural process can adequately explain. "We're seeing coordinated maneuvers," admits Dr. James Richardson from the Harvard Smithsonian Center for Astrophysics, though he speaks the words as if they taste bitter. "I've spent 30 years studying comets, and nothing in my experience prepares me for what we're observing. These objects are responding to each other's presence in real time." The natural explanations grow more strained with each passing observation. Yes, gravitational effects could cause a loosely bound cluster to reorganize as it encounters our Sun's influence. But the precision of these adjustments suggests active control rather than passive response to external forces. The objects maintain formation with a consistency that would be remarkable for human spacecraft, let alone chunks of ancient ice and rock that have been drifting through space for billions of years. Some researchers have proposed that we're witnessing the breakup of a single, massive object, perhaps held together by weak van der Waals forces or electrostatic attraction. Under this scenario, the increasing solar radiation and particle bombardment gradually weakens these bonds, causing controlled fragmentation that creates the appearance of coordinated behavior. But even this explanation fails to account for the most unsettling aspect of the observations. The secondary objects aren't just separating from the primary body, they're moving in patterns that suggest purpose, taking up positions that optimize their collective exposure to solar radiation while maintaining communication distances that would be ideal for data sharing between autonomous probes. The implications force us to confront possibilities that most scientists would prefer to ignore. If 3i Atlas represents artificial technology, it would confirm that we share the galaxy with intelligences capable of engineering on scales that dwarf human achievement. The energy requirements alone for accelerating even a small probe to interstellar velocities are staggering. To coordinate an entire swarm across such distances and timescales would require technological capabilities that we can barely imagine. The timing of this encounter adds another layer of unease to an already disturbing picture. Human radio transmissions have been leaking into space for over a century, creating an expanding bubble of electromagnetic evidence for our technological civilization. Any advanced society within roughly 100 light-years of Earth would know of our existence by now. The arrival of a potentially artificial object during the early decades of our space age could hardly be coincidental. This possibility resurrects one of the most chilling solutions to the Fermi paradox. Enrico Fermi's famous question, "Where is everybody?" "You are..." Hey Psychios has haunted astronomers for generations. With billions of stars in our galaxy and countless opportunities for life to evolve and develop technology, the universe should be buzzing with civilizations. The great silence that greets our listening efforts seems to contradict the statistical likelihood of widespread intelligence. The dark forest hypothesis offers one explanation that keeps xenobiologists awake at night. Perhaps the galaxy is indeed filled with civilizations, but they've learned to remain hidden because revealing your location invites destruction. In a universe where resources are finite and intentions unknowable, the safest strategy might be to eliminate potential competitors before they become threats. Under this terrifying scenario, 3I ATLAS could represent reconnaissance, preceding something far worse than scientific curiosity. The probe swarm might be gathering intelligence about our technological capabilities, our defensive readiness, our planetary resources. The data collected during this flyby could inform decisions about whether humanity represents a future threat that needs to be eliminated while we're still confined to a single world. The orbital mechanics of 3I ATLAS's trajectory provide little comfort for those concerned about planetary security. Unlike previous interstellar visitors that swept through our system on hyperbolic escape trajectories, this object's path brings it uncomfortably close to the inner planets during a critical period of observation. Its October approach to Mars occurs at a distance that, while seemingly vast by terrestrial standards, represents a hair's breadth in astronomical terms. More concerning is the possibility that components of the swarm might use gravitational assists from Mars or other planets to alter their trajectories, potentially establishing permanent orbits within our solar system. Computer simulations show that objects with 3I Atlas's velocity profile could, with minimal course corrections, capture themselves into long-period orbits around our Sun. The implications for human space exploration would be profound. Any permanent alien presence in our solar system would fundamentally alter the strategic landscape for future missions to Mars, the asteroid belt, or beyond. We could find ourselves sharing our cosmic neighborhood with intelligences whose intentions remain utterly opaque. NASA's response reflects the gravity of the situation. The space agency has mobilized virtually every available asset to monitor 3I ATLAS during its passage through the inner system. The James Webb Space Telescope has been redirected from its planned observations to focus exclusively on the mysterious visitor. The Hubble Space Telescope, despite its aging systems, continues to provide crucial high-resolution imagery. Even planetary missions like the Mars Reconnaissance Orbiter and the Curiosity rover have been tasked with observing the object during its closest approach to the red planet. The European Space Agency has joined this unprecedented observational campaign, repositioning its Mars Express and ExoMars Trace Gas Orbiter to study 3I Atlas from multiple angles during early October. These Mars-based observations could provide crucial parallax measurements that will help determine the true size and structure of the swarm components. Ground-based telescopes around the world have been pressed into service as well. The Very Large Telescope in Chile, the Keck Observatory in Hawaii, and dozens of smaller facilities are conducting round-the-clock monitoring. Even amateur astronomers have contributed valuable observations. Their dedication to understanding this cosmic mystery transcending professional boundaries. The data flowing from this global effort paints an increasingly complex picture. Spectroscopic analysis continues to reveal the presence of water vapor, carbon dioxide, and various organic compounds in the object's coma. These chemical signatures remain consistent with natural cometary composition, but they don't rule out more exotic possibilities. An artificial probe designed for interstellar travel might well incorporate actual cometary materials, either as camouflage or as reaction mass for propulsion systems. The organic compounds detected by Webb could represent biological contamination from the probe's creators, preserved in the deep freeze of interstellar space for millions or billions of years. The hydrogen cyanide production that has been steadily increasing as 3I-ATLAS approaches the Sun presents another puzzle. While this compound can form naturally in comets through photochemical processes, the quantities and production rates observed don't match theoretical predictions for objects of this composition. The pattern suggests either internal heat sources beyond simple solar warming or active chemical processes that have no natural analogue. Perhaps most intriguingly, the polarimetric observations reveal dust particles with optical properties unlike any known solar system material. The high degree of negative polarization suggests grain structures that formed under conditions very different from those in our local environment. This could indicate origin in a star system with different chemical abundances or stellar radiation fields. Or it could suggest manufacturing processes that produced materials with precisely engineered optical characteristics. As October deepens and 3I Atlas reaches its closest approach to the Sun, the mystery has only intensified. The object's brightness continues to increase at rates that exceed all theoretical predictions for natural outgassing. The irregular variations in luminosity suggest complex internal processes that defy easy explanation. The swarm components have begun exhibiting even more coordinated behaviors as they encounter the intense solar environment. Rather than dispersing randomly as heated cometary fragments should, they're maintaining formation while adjusting their relative positions in response to changing conditions. The precision of these maneuvers would be impressive for human spacecraft, let alone for chunks of ancient ice that have been dormant for geological ages. Radio telescopes around the world have been scanning 3I-ATLAS for any sign of artificial transmissions, though so far the search has yielded only the natural emissions expected from heated gases and dust. But the absence of detectable radio signals doesn't necessarily indicate natural origin. Any civilization capable of interstellar travel would likely use communication methods far more sophisticated than the crude electromagnetic broadcasts that mark human technology. The psychological impact on the astronomical community has been profound. Researchers who have devoted their careers to studying the natural cosmos find themselves grappling with observations that challenge the very foundations of their understanding. The possibility that we might be witnessing our first clear evidence of extraterrestrial intelligence forces confrontation with questions that extend far beyond astronomy into philosophy, theology, and the deepest aspects of human existence. What does it mean to be human if we're not alone in the universe? How do we maintain our sense of cosmic significance if we're merely one among countless technological civilizations? And most pressingly, how do we prepare for contact with intelligences that might view us as competitors rather than colleagues? The answers to these questions may depend on data that won't be available for months or years. 3I Atlas will disappear behind the Sun during its closest approach in late October, hidden from Earth-based observations during the very period when solar heating should trigger maximum activity. When it emerges from solar conjunction in late November, it will be racing away from the inner system, already beginning its journey back to the interstellar void. But the post-perihelion observations could prove even more revealing than the approach phase. If 3I Atlas is indeed artificial, its behavior after closest solar approach might provide the clearest evidence yet. Natural comets typically show decreased activity as they move away from the Sun, but artificial probes might exhibit entirely different patterns of behavior once their reconnaissance mission is complete. The trajectory analysis shows that 3I Atlas will pass within the orbit of Jupiter in March 2026, providing one final opportunity for detailed observation before it leaves our solar system forever. By that time, we should have enough data to determine definitively whether we've encountered natural phenomena or something far more extraordinary. The philosophical implications of either answer are staggering. If 3I Atlas proves to be natural, it will force us to revise our understanding of interstellar object populations and the processes that eject material from planetary systems. The statistical anomalies alone would require new theories about how matter is distributed throughout the galaxy. But if the evidence continues pointing toward artificial origin, we'll face an even more profound transformation of our cosmic worldview. The confirmation that we share the galaxy with other technological civilizations would represent the most significant discovery in human history, fundamentally altering our understanding of our place in the universe and our future as a species. The religious implications alone would be profound. How do the world's major faiths adapt to the reality of multiple technological civilizations? Do we represent a unique creation, or merely one example of a universal tendency toward consciousness and intelligence? These questions would reshape human philosophy and spirituality in ways we can barely begin to comprehend. The political ramifications would be equally dramatic. The knowledge that advanced alien civilizations exist would likely accelerate human space development as nations race to establish their presence beyond Earth before potential competitors arrive. The militarization of space, already a growing concern, would become inevitable as humanity prepares for possibilities we'd prefer not to contemplate. International cooperation, currently fragmented by terrestrial concerns, might finally achieve the unity that has eluded us throughout history. The recognition that we face potential external threats could provide the motivation needed to transcend national boundaries and work together as a species for the first time. But unity, born from fear, carries its own dangers. The history of human conflict suggests that external threats often lead to authoritarian responses and the suppression of individual freedoms in the name of collective security. The confirmation of alien intelligence could trigger social transformations that fundamentally alter the nature of human civilization. As 3I Atlas continues its relentless approach toward perihelion, racing through space at speeds that compress cosmic evolution into human timescales, we're left to grapple with uncertainties that strike at the core of existence itself. The next few months will determine whether we're witnessing the greatest natural mystery of our time, or the first clear evidence that we are not alone in our vast, dark, and potentially dangerous galaxy. The swarm continues its approach, maintaining formation with precision that defies every natural explanation we can devise. Behind the primary coma, in the shadow of 3I Atlas, something moves through the darkness between the stars. Something that might represent our first glimpse of intelligence beyond Earth, or the harbinger of challenges we're not prepared to face. The countdown continues, and with each passing day, the mystery deepens. Whatever secrets 3I Atlas carries from its ancient journey across the galaxy, we'll have our answers soon. Whether those answers bring wonder or terror may determine the trajectory of human civilization for generations to come. The universe has remained silent for so long that we'd grown comfortable with our solitude. But silence, as we're about to discover, might have been a blessing we never learned to appreciate. In the cold mathematics of orbital mechanics, 3I Atlas draws ever closer to its solar encounter, carrying with it the potential to transform everything we thought we knew about our cosmic neighborhood. The swarm approaches, and humanity waits with a mixture of anticipation and dread for the revelation that may finally answer Fermi's haunting question. Where is everybody? The answer we've been waiting for may reveal itself in ways we never anticipated, as the most sophisticated instruments humanity has ever built prepare to peer deeper into this cosmic enigma than ever before. But as October's chill descends across Earth's observatories, the data streaming back from our telescopes paints a picture that grows more unsettling with each passing night. Dr. Michael Torres, lead analyst for the European Southern Observatory's emergency response team, discovered something in the latest batch of spectroscopic data that made him question his own sanity. Working alone in the pre-dawn hours of October 15th, he noticed patterns in the infrared emissions that violated everything he knew about cometary behavior. The thermal signatures are all wrong, he confided to his supervisor during an encrypted video call. We're seeing heat distribution patterns that suggest internal energy sources, not solar heating, not radioactive decay, but something actively generating warmth from within multiple components of the structure. This revelation adds another layer of impossibility to an already impossible situation. Natural comets derive their activity from solar heating, which sublimes surface ices and creates the familiar tail and coma. But the thermal readings from 3I Atlas show energy signatures that precede and exceed what solar input alone could produce. It's as if the object is awakening from some primordial slumber, systems coming online after eons of dormancy. The parallels to our previous interstellar encounters make this awakening even more disturbing. When Oumuamua swept through our system, it exhibited unexplained acceleration that couldn't be attributed to normal outgassing forces. The scientific community eventually settled on exotic explanations involving hydrogen outgassing or radiation pressure effects, though many researchers remained privately skeptical. 2I Borisov, by contrast, behaved exactly as theory predicted. It outgassed water vapor and dust at rates consistent with its size and solar distance, following trajectories that matched computer models perfectly. For a brief moment, the cosmos seemed comprehensible again. Interstellar objects were just chunks of ancient ice and rock, wandering between stars like cosmic driftwood. But 3I Atlas has demolished that comfortable predictability. Where our models anticipated a single nucleus perhaps a few kilometers across, we're confronting a distributed system spanning dozens of kilometers. Where we expected random fragmentation as solar heating took its toll, we're observing coordinated repositioning that suggests active control. The latest observations from the Atacama Large Millimeter Array have revealed even more disturbing details about this coordination. As the primary body approaches its closest solar encounter, the secondary objects have begun adjusting their positions with mathematical precision. They're not drifting apart like debris should. They're optimizing their formation for maximum data collection efficiency. Look at these positioning algorithms, whispers Dr. Sarah Kim from the Jet Propulsion Laboratory, her voice barely audible during a classified briefing to NASA leadership. If I were designing a probe swarm for maximum sensor coverage of a star system, this is exactly the formation I would choose. Overlapping observation zones, redundant data paths, optimal communication distances, it's textbook swarm robotics. The natural explanations that once seemed plausible now strain credibility beyond the breaking point. Yes, tidal forces could theoretically cause controlled fragmentation of a weakly bound rubble pile. But the precision of these adjustments requires information processing capabilities that natural objects simply don't possess. Rocks and ice don't calculate optimal trajectories. They don't respond to changing conditions with coordinated maneuvers that maximize collective efficiency. Even more troubling is the discovery that the swarm components are communicating with each other. Radio telescopes monitoring 3IATLAS have detected faint but structured electromagnetic emissions passing between the various objects. The signals are too weak and too brief for detailed analysis, but their timing corresponds perfectly with observed changes in the formation's geometry. We're seeing data packets, admits Dr. Elena Rodriguez, from the Very Large Array, though she speaks the words as if they might summon demons. Short bursts of structured information, transmitted between components whenever they adjust their relative positions. It's exactly what you'd expect from autonomous probes coordinating their activities. The implications cascade through the scientific community like a shockwave. If 3I Atlas represents artificial technology, it validates decades of speculation about how advanced civilizations might explore the galaxy. The concept of self-replicating probe swarms has been a staple of scientific literature since the 1980s, when researchers realized that such systems could explore the entire Milky Way in just a few million years. The mathematics are elegant and terrifying. A single civilization that developed interstellar probe technology could, in principle, map every star system in the galaxy within a geological eye blink. Each probe would study its assigned targets, then replicate itself using local materials before dispatching copies to unexplored regions. The exponential growth would be unstoppable. But here's what keeps xenobiologists awake at night. If such probe swarms are possible, where are they? The Fermi paradox becomes even more acute when we consider automated exploration. Even if biological civilizations remain confined to their home systems, their robotic emissaries should be everywhere. The galaxy should be swarming with artificial intelligence. The dark forest hypothesis offers one chilling explanation. Perhaps the galaxy is indeed filled with probe swarms, but they're designed not for exploration, but for elimination. Advanced civilizations might deploy automated systems to identify and destroy potential competitors before they can develop their own interstellar capabilities. In this scenario, 3I Atlas could represent a threat assessment mission, gathering intelligence about human technological development and planetary defenses. The orbital mechanics of the current encounter support this unsettling possibility. Unlike random interstellar debris, 3I ATLAS approaches from the direction of the galactic plane, following a trajectory that suggests deliberate targeting of our solar system. Its path carries it through the optimal observation zone for studying interplanetary orbits, while maintaining sufficient distance to avoid immediate detection as artificial. The timing raises additional concerns. Human radio transmissions have been propagating into space for over a century, creating an expanding sphere of evidence for our technological civilization. Any monitoring system within 100 light-years would know of our existence by now. The arrival of a potentially artificial object during the early decades of our space age stretches coincidence beyond credibility. Mars presents a particular vulnerability during 3I ATLAS's approach. The red planet's position in early October places it directly in the swarm's path, though at what planetary scientists euphemistically call a safe distance of 30 million kilometers. But safety is relative when dealing with objects of unknown capability and intent. Computer simulations show that components of the swarm could use Mars's gravitational field to alter their trajectories, potentially establishing permanent orbits within our solar system. The energy requirements would be minimal for objects already traveling at interstellar velocities. A few precise course corrections could transform temporary visitors into permanent residents. The implications for human space exploration would be profound. NASA's ambitious plans for Mars colonization assume we'll have the red planet to ourselves, free to develop its resources and establish humanity's first foothold beyond Earth. The presence of alien technology in Martian orbit would fundamentally alter that equation, transforming exploration into potential confrontation. The response from global space agencies reflects growing alarm beneath official statements of scientific curiosity. The James Webb Space Telescope has abandoned its scheduled observations of distant galaxies to focus exclusively on 3I ATLAS, Every available space-based asset has been redirected to monitor the approaching swarm. Even classified military satellites have been pressed into service. Their capabilities officially non-existent, but their data streams flowing into analysis centres around the world. The European Space Agency's Mars-based missions provide a unique perspective on the encounter. The Mars Express and ExoMars Trace Gas Orbiter have been repositioned to observe 3I Atlas from angles impossible from Earth. Their instruments calibrated to detect anything unusual in the object's behaviour or emissions. These observations could provide the definitive evidence needed to determine the swarm's true nature. Ground-based telescopes continue their vigil as well, though atmospheric interference limits their effectiveness compared to space-based platforms. The Very Large Telescope in Chile, the Keck Observatory in Hawaii, and dozens of smaller facilities maintain round-the-clock monitoring, their data streams flowing into supercomputers that struggle to process the implications of what they're recording. Amateur astronomers have joined this unprecedented observational campaign, their dedication transcending professional boundaries. Backyard telescopes around the world contribute photometric measurements and positional data, creating a distributed observation network that no single agency could duplicate. Their collective effort represents humanity's grassroots response to a mystery that could redefine our place in the universe. The chemical analysis continues to yield puzzling results. Webb's spectroscopic data reveals a complex mixture of water vapor, carbon dioxide, and organic compounds consistent with natural cometary composition. But the ratios are wrong, the isotopic signatures don't match solar system norms, and the production rates vary in patterns that suggest active management rather than passive sublimation. The hydrogen cyanide emissions have become particularly concerning. This toxic compound, rare in natural comets, continues to increase at rates that exceed all theoretical predictions. On Earth, hydrogen cyanide is primarily associated with industrial processes and certain biological systems. Its presence in an interstellar object raises uncomfortable questions about the chemical processes occurring within the swarm. Perhaps most disturbing are the organic compounds detected in trace quantities throughout the coma. These complex molecules, including several that serve as biological precursors on Earth, shouldn't survive the radiation environment of interstellar space. Their preservation suggests either recent formation or sophisticated protection mechanisms that have no natural analogue. The polarimetric observations paint an equally strange picture. Light reflected from the swarm's dust particles shows characteristics unlike any known solar system material. The particles appear to have been manufactured rather than naturally formed, their optical properties optimized for specific wavelengths in ways that serve no obvious natural purpose. It's as if someone designed these particles to interact with starlight in very specific ways, explains Dr. Jennifer Walsh from the Anglo-Australian Observatory. The polarization signatures suggest materials with engineered microstructures, possibly designed to enhance or suppress certain types of radiation. That's not how natural dust behaves. These revelations force us to confront possibilities that challenge the very foundations of our cosmic worldview. If 3I Atlas represents artificial technology, we're not just witnessing our first contact with extraterrestrial intelligence. We're encountering a civilization so advanced that they can engineer matter at the molecular level, creating materials with properties that seem to violate natural laws. The philosophical implications extend far beyond astronomy into the deepest questions of existence itself. What does it mean to be human if we're merely one among countless technological civilizations? How do we maintain our sense of cosmic significance if we're being studied like bacteria in a petri dish? And most pressingly, how do we respond to contact with intelligences that might view us as competitors rather than colleagues? The religious communities grapple with equally profound questions. Major faiths around the world have begun issuing careful statements about the theological implications of extraterrestrial intelligence. The Vatican's Astronomical Observatory has published papers exploring how the discovery of alien civilizations might affect Catholic doctrine. Islamic scholars debate whether consciousness represents a universal gift from Allah or a unique blessing bestowed upon humanity. The political ramifications ripple through governments worldwide. Classified briefings to heads of state outline scenarios ranging from benevolent scientific exchange to existential threats requiring unprecedented international cooperation. Military planners dust off contingency protocols last updated during the Cold War, adapting them for challenges that transcend terrestrial concerns. The economic implications alone would reshape global civilization. The confirmation of alien technology would trigger massive investments in space-based industries, as nations race to establish their presence beyond Earth before potential competitors arrive. The militarization of space, currently proceeding at a measured pace, would accelerate exponentially as humanity prepares for possibilities we'd rather not contemplate. But beneath the grand strategic concerns lie more immediate fears that keep planetary defense experts awake at night. What if 3i Atlas isn't here for scientific observation? What if this apparent reconnaissance mission precedes something far more ominous? The history of contact between civilizations on Earth offers few encouraging precedents for encounters between vastly different technological capabilities. The approach toward perihelion continues relentlessly, each day bringing 3i Atlas closer to its solar encounter and deeper into our detection capabilities. The swarm maintains its formation with precision that would be remarkable for human spacecraft, let alone chunks of ancient ice that have been dormant for billions of years. The coordinated maneuvers continue, adjustments that optimize sensor coverage while maintaining communication links between components. Radio telescopes strain to detect any sign of intentional transmissions, though the absence of obvious signals doesn't necessarily indicate natural origin. Any civilization capable of interstellar travel would likely use communication methods far more sophisticated than the electromagnetic broadcasts that mark human technology. Quantum entanglement, gravitational wave modulation, or techniques we haven't even imagined could provide instantaneous communication across any distance. The infrared observations reveal another disturbing pattern. As 3i Atlas approaches the Sun, its thermal emissions show periodic variations that correspond to no known natural process. The fluctuations suggest internal mechanisms cycling on and off, perhaps conserving energy or managing heat distribution throughout the swarm. It's the thermal signature of technology, not geology. Most unsettling of all are the gravitational anomalies detected by sensitive instruments monitoring the swarm's trajectory. Tiny deviations from predicted paths suggest mass redistributions within the formation, as if components are adjusting their internal structure in response to changing conditions. Natural objects don't exhibit such behavior. Only artificial systems modify themselves based on environmental feedback. The psychological impact on the astronomical community has been profound. Researchers who devoted their careers to studying the natural cosmos find themselves grappling with observations that challenge everything they thought they knew about how the universe works. The possibility that we're witnessing clear evidence of extraterrestrial technology forces confrontation with questions that extend far beyond science into philosophy, theology, and the deepest aspects of human existence. Some scientists have begun suffering what colleagues privately call cosmic anxiety disorder, a form of existential dread triggered by the realization that humanity might not be alone in the universe. Support groups have formed at major observatories, where researchers share their fears about what contact with advanced alien civilizations might mean for human autonomy and survival. The media response has been carefully managed by government agencies concerned about public panic. Official statements emphasize the scientific value of studying interstellar objects while downplaying the more speculative aspects of the observations. But information leaks inevitably occur, and online communities buzz with theories ranging from plausible to paranoid. Social media platforms struggle to contain misinformation about 3IATLAS, as conspiracy theorists blend legitimate scientific concerns with wild speculation about alien invasions and government cover-ups. The challenge of communicating complex astronomical observations to the general public becomes even more difficult when those observations challenge fundamental assumptions about our place in the cosmos. As October reaches its climax and 3I Atlas approaches its closest solar encounter, the mystery has only deepened. The swarm continues to exhibit behaviors that strain natural explanations beyond the breaking point. The coordinated positioning, the thermal management, the communication signals, the manufactured dust particles all point toward artificial origin with increasing certainty. Yet the implications of that conclusion are so profound that many researchers continue grasping for alternative explanations, no matter how implausible. The cognitive dissonance between what the data suggests and what we're prepared to accept creates a crisis of scientific confidence that parallels the theological upheavals of the Renaissance. The final answer may come sooner than anyone anticipated. Advanced computer models predict that 3I Atlas will reach maximum solar heating in late October, triggering whatever processes have remained dormant during its long interstellar journey. If the swarm is indeed artificial, this solar encounter might activate systems that have been powered down for millions of years. The world's most sophisticated telescopes prepare for humanity's most important observation. In the coming days, we may finally learn whether we're witnessing nature's strangest creation or our first undeniable proof that intelligence exists beyond Earth. The data will either confirm our cosmic solitude or shatter it forever, transforming not just astronomy, but the entire trajectory of human civilization. The swarm approaches its moment of revelation, carrying with it secrets that could redefine everything we thought we knew about our place in the vast, dark, and potentially populated cosmos. Behind the primary coma, in the shadow of 3IATLAS, something moves through the interstellar night, something that might represent our first glimpse of artificial intelligence beyond Earth, or the harbinger of challenges we're utterly unprepared to face. The countdown to perihelion continues, and with it, our race against time to understand what we're truly confronting. The universe has remained silent for so long that we'd grown comfortable assuming we were alone. But as 3I Atlas draws ever closer to its solar encounter, that comforting assumption crumbles beneath the weight of evidence that defies every natural explanation we can devise. In the cold equations of orbital mechanics, destiny approaches at 58 kilometers per second. Whether that destiny brings wonder or terror may depend on secrets hidden in the shadow of the swarm, racing toward us through the darkness between the stars. The mystery deepens with each passing hour, and humanity holds its breath, waiting to discover what other impossible things might be lurking in the wake of this cosmic visitor that should not exist. The gravitational dance unfolding in our cosmic neighborhood has taken a turn that challenges not just our understanding of physics, but our most fundamental assumptions about what's possible in the universe. As 3I Atlas hurtles toward its November reappearance from behind the sun, something extraordinary is emerging from the data that's forcing astronomers to confront a reality they never prepared for. Dr. Patricia Blackwood, chief astronomer at the International Dark Sky Observatory, made a discovery in the early hours of November 3rd that she initially dismissed as instrument error. Working through terabytes of post-perihelion data, she noticed anomalies in the gravitational field measurements that suggested additional mass concentrations trailing behind the main swarm formation. At first, I thought we were seeing gravitational lensing effects from the sun, she explained, during an emergency conference call with observatory directors worldwide. But as I refined the calculations, it became clear that we're detecting discrete objects following in 3I-ATLAS's wake, objects that weren't there during the approach phase. The implications hit the astronomical community like a seismic shock. If Dr. Blackwood's analysis proves correct, 3I Atlas didn't just bring a coordinated swarm of objects into our solar system, it deployed them. During its passage behind the Sun, hidden from Earth's observation, something extraordinary occurred. The swarm didn't just survive its solar encounter, it multiplied. The mathematics of what they're observing defies every model of natural behavior. Computer simulations show that any debris field should have been scattered by solar radiation pressure and the Sun's gravitational field. Instead, the new objects appear to be organizing themselves into stable trailing formations, maintaining precise distances behind the primary swarm as it begins its journey back toward interstellar space. "We're looking at deployment pattern, VA," whispers Dr. Marcus Chen from the Palomar Observatory, his voice barely audible during classified briefings to government officials. Whatever happened during perihelion, it wasn't random fragmentation. These new objects have taken up positions that optimize their collective observation capabilities while maintaining communication links with the departing swarm. The discovery forces us to reconsider everything we thought we understood about 3I-ATLAS's mission. If this truly represents artificial technology, the solar encounter wasn't just a gravitational flyby, it was a delivery system, using our own star's energy to activate and deploy secondary payloads that had remained dormant during the long interstellar journey. The natural explanations that once seemed plausible now collapse under scrutiny. Solar heating could theoretically cause delayed outgassing that creates new debris, but the positioning patterns show mathematical precision that random processes simply cannot achieve. These aren't chunks of ice and rock drifting apart after thermal stress. They're artificial constructs taking up predetermined positions in our solar system. Radio telescopes monitoring the post-perihelion environment have detected a dramatic increase in structured electromagnetic emissions. The faint signals that once passed between swarm components have evolved into a complex communication network spanning millions of kilometers. The data packets are too sophisticated for current analysis, but their timing corresponds perfectly with observed changes in the new object's trajectories. "We're witnessing the activation of a distributed intelligence," admits Dr. Sarah Volkov from the Arecibo Successor Facility, though she speaks the words as if they might trigger catastrophe. Whatever systems were dormant during the approach phase are now fully operational. The solar encounter provided the energy needed to boot up technologies we can barely comprehend. The comparison to our previous interstellar encounters makes this development even more unsettling. When Oumuamua swept through our system, it exhibited mysterious acceleration that couldn't be explained by normal cometary processes. The scientific community eventually settled on exotic natural explanations, though many researchers remained privately skeptical about whether those mechanisms could account for the observed behavior. 2I Borisov provided blessed relief from such mysteries, behaving exactly as theoretical models predicted. It outgassed water vapor and dust at predictable rates, followed trajectories that matched computer simulations, and departed our system without leaving any trace of its passage. For a brief moment, the universe made sense again, but 3I Atlas has shattered that comfortable predictability in ways that make Oumuamua's anomalies seem trivial by comparison. Where we expected a single interstellar comet following natural laws, we're confronting a distributed system that appears to be actively colonizing our solar system with technological constructs of unknown purpose and capability. The positioning of these new objects suggests surveillance rather than scientific exploration. They've established observation posts that provide comprehensive coverage of the inner planetary orbits, with particular emphasis on Earth-Moon space and the trajectory corridors used by human spacecraft. It's the deployment pattern you'd expect from an intelligence-gathering operation. not random debris from a fragmenting comet. The implications for planetary security have triggered classified assessments at the highest levels of government. The objects trailing behind 3I ATLAS occupy positions that would be ideal for monitoring human space activities while remaining difficult to detect from Earth-based telescopes. They're essentially invisible unless you know exactly where to look, hidden in the gravitational shadows of larger solar system bodies. We're dealing with stealth technology, explains Dr. Jennifer Walsh during a restricted briefing to NATO Space Command. These objects have radar cross-sections approaching zero and thermal signatures that barely register above background noise. If we weren't tracking them from their deployment, we might never have known they were there. The military implications cascade through defense establishments worldwide. If alien technology has established permanent surveillance posts in our solar system, every aspect of human space activity is potentially compromised. Communication satellites, space stations, planetary missions, even terrestrial military assets could be under constant observation by intelligences whose capabilities and intentions remain utterly opaque. The psychological impact on the space science community has been devastating. Researchers who devoted their careers to studying the natural cosmos find themselves grappling with evidence that our solar system has become a theatre of operations for technologies beyond human comprehension. The comfortable assumption that we're alone in our cosmic neighbourhood has evaporated, replaced by the chilling realization that we may have been under surveillance for much longer than anyone imagined. Some scientists have begun questioning whether other anomalous objects in our solar system might represent earlier deployments from previous interstellar visitors. The asteroid Oumuamua, initially classified as natural despite its unusual properties, suddenly seems far more suspicious in light of what we're learning about 3I ATLAS. How many other artificial constructs might be hiding among the natural debris of our solar system? The religious implications have sent shockwaves through faith communities worldwide. The Vatican's Astronomical Observatory has issued carefully worded statements about the theological significance of confirming extraterrestrial intelligence. While Islamic scholars debate whether the Quran's references to life throughout the cosmos anticipated exactly this type of discovery, Buddhist and Hindu traditions, with their concepts of multiple inhabited worlds, seem better prepared for such revelations than Western monotheistic religions. The economic ramifications promise to reshape global civilization within decades. Stock markets have experienced unprecedented volatility as investors struggle to price in the implications of confirmed alien technology. Space-related industries have seen explosive growth as governments and private corporations race to establish defensive capabilities beyond Earth's atmosphere. The militarization of space, previously proceeding at a measured pace constrained by international treaties, has accelerated exponentially. Nations that once cooperated on peaceful space exploration now view orbital assets as strategic necessities for planetary defense. The fragile consensus that kept weapons out of space is crumbling as humanity prepares for challenges that transcend terrestrial concerns. International cooperation faces unprecedented strains as countries pursue independent responses to the alien presence. Some advocate for aggressive investigation of the deployed objects, while others argue for careful non-interference to avoid provoking unknown responses. The United Nations has established a special committee on extraterrestrial contact, but consensus remains elusive when the stakes involve species-level survival. The scientific response has been equally fractured. Some researchers advocate for attempting communication with the alien constructs, arguing that peaceful contact represents humanity's best hope for beneficial exchange with advanced civilizations. Others warn that any such attempts could trigger defensive responses from technologies designed to eliminate potential threats. The dark forest hypothesis has gained disturbing credibility as analysts study the deployment patterns. If the galaxy is indeed filled with civilizations hiding from each other, The arrival of obvious surveillance technology suggests that humanity has been classified as a potential threat requiring monitoring. We may have graduated from cosmic insignificance to becoming targets for elimination by intelligences that view rising technological species as existential risks. The trajectory analysis shows that several of the deployed objects have taken up positions that would allow them to intercept Earth-based spacecraft or communications. They're essentially manning the choke points through which human expansion into the solar system must pass. It's the positioning strategy you'd expect from an occupying force establishing control over strategic resources and transportation corridors. Even more disturbing is the realization that the objects show signs of autonomous operation. They adjust their orbits in response to changing conditions without any apparent input from the departing 3I ATLAS swarm. Whatever intelligence controls them has established independent decision-making capabilities that could persist long after their parent system disappears back into interstellar space. The energy signatures detected by space-based observatories suggest that the objects are not passive monitors, but active systems capable of significant output. Thermal imaging reveals internal processes that require substantial power generation, while gravitational measurements indicate mass distributions consistent with sophisticated machinery rather than natural rock and ice formations. These aren't just surveillance drones, but, warns Dr. Elena Rodriguez during classified briefings to congressional leadership. The power requirements suggest manufacturing capabilities, communications arrays, possibly even defensive systems. We're looking at a permanent alien industrial presence in our solar system. The implications for human space exploration are profound. NASA's ambitious plans for Mars colonization must now account for the possibility of alien surveillance and potential interference. The assumption that we could develop solar system resources at our own pace has been shattered by the recognition that we're no longer alone in our cosmic neighborhood. Private space companies face even greater uncertainties. SpaceX, Blue Origin, and other commercial ventures have invested billions in technologies designed for a solar system devoid of alien intelligence. The discovery of advanced surveillance networks forces complete reassessment of business models based on exclusive human access to space resources. The Mars colonies that seemed inevitable just months ago now face questions about sovereignty and security that have no precedent in human experience. How do you establish territorial claims on planets that might already be under observation by civilizations with superior technological capabilities? What rights do humans have to solar system resources if other intelligences arrived first? The philosophical implications extend even deeper than practical concerns about space development. The confirmation of alien intelligence forces humanity to confront fundamental questions about consciousness, intelligence, and our place in the cosmic hierarchy. Are we a young species taking its first tentative steps toward interstellar civilization? Or are we unwitting subjects in an experiment conducted by entities beyond our comprehension? The detection of what appears to be manufacturing activity within some of the deployed objects raises the most chilling possibility of all. If alien technology can reproduce itself using solar system materials, the current deployment might represent only the initial phase of a much larger operation. Self-replicating systems could transform our entire cosmic neighborhood within decades, converting asteroids and planetary resources into forms optimized for alien purposes. The von Neumann probe scenario, long a staple of theoretical discussions about interstellar exploration, suddenly seems terrifyingly plausible. A single self-replicating system could, given sufficient time and resources, transform an entire galaxy. The exponential growth would be unstoppable once initiated, consuming stellar systems faster than any biological civilization could react or defend itself. Radio telescopes continue monitoring the alien constructs for any sign of communication attempts directed toward Earth. So far, The detected emissions appear to be internal system coordination rather than efforts at contact. This silence might indicate that we're considered too primitive for meaningful dialogue, or it could suggest that contact protocols await developments we haven't yet imagined. The absence of obvious communication attempts doesn't necessarily indicate benign intent. Military strategists point out that surveillance operations typically maintain communication silence to avoid detection and preserve operational security. The alien constructs might be gathering intelligence for decision-makers who won't reveal themselves until they've completed their assessment of human capabilities and intentions. The timeline for resolution remains frustratingly uncertain. The deployed objects show no signs of departing with the main 3I Atlas swarm, suggesting they represent permanent additions to our solar system's population. Whatever their purpose, we may be living with alien technology in our cosmic neighborhood for the indefinite future, fundamentally altering the context for all human activities beyond Earth's atmosphere. Ground-based telescopes continue tracking the departing 3IA TLAS formation as it begins its journey back toward interstellar space. The main swarm maintains its coordinated formation while gradually accelerating away from the Sun, but the objects it left behind show no signs of following. They've taken up permanent residence in our solar system, silent sentinels whose purpose remains as mysterious as their origin. The psychological adaptation to this new reality has proven difficult for both scientists and the general public. Humans evolved in a universe that seemed vast but empty, where intelligence appeared to be a rare accident confined to a single world. The confirmation that we share our cosmic neighborhood with artificial constructs of unknown origin and purpose challenges every assumption about humanity's cosmic significance. Support groups have formed in major cities to help people process the existential implications of confirmed alien intelligence. Therapists report unprecedented demand for services addressing what psychologists now recognize as cosmic anxiety disorder, a form of existential dread triggered by the realization that humanity might be subject to observation and potential control by superior intelligences. The educational implications are equally profound. Textbooks must be rewritten to account for the possibility of alien technology in our solar system. Children growing up in this new reality will have fundamentally different assumptions about humanity's place in the universe than any previous generation. The cosmic perspective that once seemed abstract and distant has become immediate and personal. Religious institutions struggle to adapt theological frameworks developed for a universe where humanity represented the only known intelligence. The discovery of alien technology forces re-examination of concepts like divine purpose, human uniqueness, and the meaning of consciousness itself. Some faiths prove more adaptable than others to the reality of multiple technological civilizations. The cultural impact extends beyond formal institutions into art, literature, and popular entertainment. Science fiction, once dismissed as mere fantasy, suddenly seems prophetic in its exploration of contact scenarios and their implications for human civilization. Writers and filmmakers find reality outpacing their most imaginative speculations about alien encounters. As winter deepens in Earth's northern hemisphere and 3I Atlas continues its journey back toward interstellar space, the objects it deployed remain active in our solar system. Their thermal signatures suggest ongoing operations, while their positioning indicates comprehensive surveillance of human space activities. We've become subjects of study by intelligences whose capabilities and motivations remain utterly opaque. The mystery that began with the discovery of an unusual interstellar comet has evolved into humanity's first confirmed encounter with extraterrestrial technology. The comfortable assumption that we're alone in the universe has been replaced by the unsettling recognition that we're being watched by entities whose purposes we cannot fathom and whose powers we cannot measure. The swarm's deployment has fundamentally altered our cosmic situation. We're no longer a species taking its first steps toward interstellar civilization in a universe that seemed empty and available for exploration. We've become participants in a galactic community whose rules we don't understand and whose other members remain hidden in the shadows between stars. Behind the fading light of 3i Atlas, racing back toward the interstellar void, the mystery deepens with each passing observation. The objects left in our solar system continue their silent vigil, mechanical eyes that never blink, watching humanity's every move as we struggle to comprehend what their presence means for our future among the stars. The universe has revealed itself to be far stranger and more crowded than we ever dared imagine. What other secrets might be lurking in the darkness between worlds, waiting for the right moment to reveal themselves? What other impossible things might be hiding in the shadow of technologies so advanced that they seem like magic to our still primitive understanding? The countdown to understanding continues, but the questions multiply faster than the answers. In the cold equations of interstellar politics, humanity has become a player in a game whose rules we never learned and whose stakes we're only beginning to comprehend. The silence that once comforted us with the illusion of cosmic solitude has been shattered forever, replaced by the watching eyes of intelligences whose next move remains as mysterious as the darkness from which they emerged. The questions that emerged from those initial observations have evolved into something far more complex than anyone anticipated. As December's chill settles across Earth's observatories, the data streaming from our most sophisticated instruments continues to challenge every assumption we've made about what's possible in the vast emptiness between stars. Dr. Rebecca Martinez, coordinator of the Global Interstellar Object Response Network, discovered something in the latest orbital mechanics data that fundamentally altered her understanding of what they were tracking. Working through calculations that should have been routine, she noticed patterns that violated the basic principles of how objects behave under gravitational influence. The secondary objects aren't just maintaining formation, she reported during an encrypted briefing to international space agencies. They're exhibiting what can only be described as active station keeping. Natural debris doesn't do this. Rocks and ice don't calculate optimal positions and then adjust their trajectories to maintain them. This revelation transforms the mystery of 3i Atlas from an astronomical curiosity into a potential crisis that touches the very foundations of human security. The precision with which these objects maintain their relative positions suggests computational capabilities that exceed anything in our technological arsenal. We're not dealing with fragments of ancient ice drifting apart under solar influence. We're confronting a distributed system that operates according to principles we've never encountered. The comparison with previous interstellar visitors makes this coordination even more disturbing. When Oumuamua tumbled through our solar system in 2017, its mysteries remained within the bounds of natural phenomena, however exotic. The cigar-shaped object's unexplained acceleration could be attributed to hydrogen outgassing or radiation pressure effects, strange but ultimately comprehensible processes that fit within our understanding of physics. 2i Borisov restored our confidence in predictable cosmos. This interstellar comet behaved exactly as theory demanded, outgassing water vapor and carbon monoxide at rates that matched computer models perfectly. Its trajectory followed the mathematical curves predicted by celestial mechanics, and its departure left no trace of anomalous behavior. The universe made sense again, at least temporarily, but the system we're now tracking behind 3i Atlas operates according to different rules entirely. Where physics predicts random dispersal of cometary fragments, we observe coordinated repositioning. Where thermodynamics demands energy dissipation, we detect active power management. Where chaos should reign, we find order of a type that suggests intelligence rather than accident. The latest observations from the James Webb Space Telescope have revealed structures within the trailing formation that defy every natural explanation scientists can devise. High-resolution infrared imaging shows geometric patterns in the dust distribution that appear engineered rather than evolved. The particle alignments create interference patterns that could only result from deliberate organization at the molecular level. We're seeing nanotechnology, admits Dr. Kevin Park from the Space Telescope Science Institute, though he speaks the words with obvious reluctance. The dust grains exhibit crystalline structures that couldn't form naturally in the radiation environment of interstellar space. Someone or something manufactured these particles with properties optimized for specific optical and electromagnetic functions. The implications cascade through the scientific community like a shockwave that continues to amplify rather than diminish. If artificial intelligence has deployed manufactured materials in our solar system, we're not just witnessing our first contact with extraterrestrial technology. We're confronting evidence of engineering capabilities that transcend our most ambitious technological dreams. The energy signatures, detected throughout the trailing formation, paint an equally unsettling picture. Thermal imaging reveals heat distribution patterns that suggest internal power sources operating at efficiencies approaching theoretical limits. Whatever systems drive these objects extract energy from their environment with a sophistication that makes our best solar panels seem primitive by comparison. Radio astronomy facilities around the world have detected increasingly complex communication patterns linking the various components of the formation. The data packets flowing between objects show error correction algorithms and compression techniques that surpass anything in human information technology. We're eavesdropping on conversations conducted in languages we can't translate by intelligences we can't comprehend. The bandwidth requirements alone should be impossible, explains Dr. Sarah Chen from the Very Large Array Facility. They're transmitting terabytes of information across millions of kilometers with error rates approaching zero. The signal processing capabilities required for such communication exceed anything we could build with current technology. Manbarshi, the natural explanations that once seemed plausible, have collapsed under the weight of accumulating evidence. Gravitational effects could theoretically cause some degree of formation flying among debris fragments, but the precision observed requires active control systems. Solar radiation pressure might explain some trajectory modifications, but not the coordinated maneuvers that optimize collective sensor coverage. Even the most exotic natural phenomena fail to account for what we're observing. Electromagnetic interactions between charged particles could create temporary alignments, but the stability of the formation across varying solar wind conditions suggests powered systems maintaining optimal configurations despite environmental changes. The possibility that we're witnessing the deployment of artificial probe swarms forces us to reconsider fundamental assumptions about interstellar exploration and the prevalence of technological civilizations. The concept of self-replicating robotic explorers has been a staple of scientific speculation for decades, but encountering actual evidence of such systems transforms theoretical possibility into immediate reality. The mathematics of probe swarm exploration are elegantly terrifying. A single civilization that developed self-replicating interstellar technology could map every star system in the galaxy within a few million years. Each probe would study assigned targets, then manufacture copies of itself using local materials before dispatching them to unexplored regions. The exponential growth would be unstoppable once initiated. But here's what transforms this from scientific fascination to existential dread. If such probe swarms are possible, where are all the others? The Fermi paradox becomes even more acute when we consider automated exploration. Even if biological civilizations remain confined to their home systems, their robotic emissaries should be everywhere. The galaxy should be swarming with artificial intelligences of various origins and purposes. One chilling explanation that keeps xenobiologists awake at night is the dark forest hypothesis. Perhaps the galaxy really is filled with probe swarms, but not for peaceful exploration. Instead, civilizations might deploy automated systems designed for threat assessment and elimination, seeking to identify and destroy potential competitors before they can develop their own interstellar capabilities. Under this terrifying scenario, the objects trailing behind 3I-ATLAS could represent reconnaissance, preceding something far more ominous than scientific curiosity. The probe swarm might be gathering intelligence about human technological development, planetary defenses, and resource distribution. The data collected during this observation phase could inform decisions about whether humanity represents a future threat requiring elimination while we're still confined to a single world. The trajectory analysis provides little comfort for those concerned about planetary security. The trailing objects have established positions that provide comprehensive surveillance coverage of Earth-Moon space and the primary corridors used by human spacecraft. They're essentially monitoring our every move beyond the atmosphere while remaining largely invisible to our detection systems. We're dealing with a distributed intelligence that knows more about our space capabilities than we do ourselves, warns Dr. Jennifer Walsh during classified briefings to defense officials. They can track every satellite launch, every space station maneuver, every interplanetary mission. We've lost the privacy of our own solar system. The implications for future space exploration are profound and disturbing. Human expansion beyond Earth must now proceed under the assumption of constant surveillance by entities whose capabilities and intentions remain utterly opaque. The comfortable era when we could develop space technologies at our own pace has ended, replaced by the recognition that we're participants in a larger galactic community whose rules we don't understand. Mars presents particular vulnerabilities during this extended observation period. The red planet's strategic importance as humanity's first potential foothold beyond Earth makes it an obvious target for alien intelligence gathering. Any probe swarm assessing human expansion capabilities would naturally focus on our Mars-related activities and infrastructure. The timing of permanent settlements on Mars suddenly becomes a matter of species-level security rather than mere exploration milestone. Establishing self-sufficient colonies before potential alien intervention could ensure human survival, even if Earth faces existential threats. But those same colonies could also trigger defensive responses from monitoring systems designed to prevent the emergence of new interstellar civilizations. NASA's response reflects growing alarm beneath official statements emphasizing scientific opportunity rather than security concerns. The space agency has quietly accelerated development of next-generation surveillance systems designed to monitor the alien constructs while avoiding actions that might be interpreted as aggressive. It's a delicate balance between gathering necessary intelligence and avoiding provocative behavior. The European Space Agency faces similar challenges as their Mars-based missions continue observing the trailing formation from unique vantage points. The data flowing from Mars Express and the ExoMars Trace Gas Orbiter provides crucial insights into alien technology operations, but it also risks drawing unwanted attention to human assets in Martian orbit. Private space companies find themselves grappling with uncertainties that no business plan could have anticipated. SpaceX's ambitious Mars colonization timeline must now account for the possibility of alien interference or territorial disputes over planetary resources. Blue Origin's lunar development projects face questions about sovereignty in a solar system that might already have prior claims established by superior technologies. The international cooperation that seemed essential for addressing climate change and other global challenges has become even more critical as humanity confronts potential external threats. Yet the same competitive instincts that drive technological innovation also fragment our species' response to challenges that transcend national boundaries. Some nations advocate for aggressive investigation of the alien constructs, arguing that understanding their capabilities represents our best hope for effective defense against potential threats. Others prefer careful non-interference, fearing that provocative actions could trigger responses we're not prepared to handle. The United Nations Special Committee on Extraterrestrial Contact remains deadlocked on fundamental questions about how to proceed. The philosophical implications extend far beyond practical concerns about space security and exploration. The confirmation of artificial intelligence operating in our solar system forces humanity to confront fundamental questions about consciousness, purpose, and our significance in the cosmic hierarchy. Are we a young species taking tentative steps toward interstellar civilization, or are we experimental subjects being evaluated by entities whose existence transcends our comprehension? Religious institutions worldwide continue struggling to adapt theological frameworks that assumed human uniqueness in creation. The discovery of alien intelligence challenges concepts of divine purpose and special creation that form the foundation of many faith traditions. Some denominations prove more adaptable than others to the reality of multiple technological civilizations sharing the universe. The cultural impact ripples through art, literature, and popular consciousness as humanity grapples with the psychological adjustment required by confirmed alien presence. Science fiction suddenly seems prophetic rather than fantastical, while educational systems scramble to prepare students for a reality that previous generations never imagined possible. Economic implications promise to reshape global civilization within decades as investors struggle to price securities in markets where alien technology represents an unknown variable. Space-related industries experience explosive growth, while traditional Earth-based sectors face uncertainty about long-term viability in a universe where human activities might be subject to external oversight or interference. The militarization of space accelerates exponentially as nations recognize that orbital assets have become strategic necessities for planetary defense rather than mere commercial or scientific tools. International treaties that once kept weapons out of space crumble under pressure from security concerns that transcend terrestrial politics. As the winter solstice approaches and Earth reaches its maximum distance from the Sun, the objects deployed by 3i Atlas continue their patient observation of human activities. Their thermal signatures suggest ongoing operations powered by energy sources that show no signs of depletion. Whatever systems drive these constructs appear designed for extended operation, measured in geological rather than human timescales. The psychological adaptation to permanent alien presence in our solar system has proven more difficult than anyone anticipated. Support groups in major cities help people process the existential implications of confirmed extraterrestrial intelligence, while therapists report unprecedented demand for services addressing cosmic anxiety disorders triggered by the realization that humanity might be subject to evaluation by superior entities. Ground-based telescopes maintain their vigil as advanced computer modeling attempts to predict the long-term behavior of the alien constructs. The mathematical simulations suggest that the objects possess sufficient capability to remain operational for thousands or potentially millions of years, fundamentally altering the context for all future human expansion beyond Earth's protective atmosphere. The departed 3i Atlas formation continues its journey back toward interstellar space, gradually fading from our telescopes as distance and solar interference reduce signal strength. But the technology it deployed shows no signs of following its parent system into the cosmic void. These constructs appear to represent permanent additions to our solar system's population, silent guardians whose purpose remains as mysterious as their origin. Radio telescopes strain to detect any sign of communication attempts directed toward Earth, but the alien systems maintain their operational silence. This absence of obvious contact might indicate that we're considered too primitive for meaningful dialogue, or it could suggest that communication protocols await developments we haven't yet imagined. The detection of what appears to be self-maintenance activity within some constructs raises the possibility that we're witnessing not just surveillance technology, but the seeds of a much larger presence. If alien systems can repair and upgrade themselves using solar system materials, the current deployment might represent only the initial phase of a transformation process that could reshape our entire cosmic neighborhood. The von Neumann probe scenario, long relegated to theoretical speculation, suddenly seems disturbingly plausible. Self-replicating systems could convert asteroid belts and planetary resources into forms optimized for alien purposes within decades. The exponential growth would be unstoppable once initiated, consuming our solar system faster than any human response could prevent or control. Yet the careful positioning and apparently passive behavior of the constructs suggests something more subtle than aggressive colonization. The alien systems appear content to observe rather than intervene, at least for now. This restraint might indicate a benevolent scientific curiosity, or it could represent the patience of intelligences that measure success across cosmic rather than human timescales. The mystery deepens with each passing observation, as humanity struggles to comprehend what the permanent presence of alien technology means for our future among the stars. We've become participants in a galactic community whose other members remain hidden, subject to evaluation by entities whose standards and judgments we cannot fathom. Behind the fading trajectory of 3I Atlas, now racing back toward the interstellar darkness from which it emerged, the constructs it deployed continue their silent vigil. Mechanical sentinels that never sleep, watching humanity's every move as we take our first tentative steps toward becoming an interstellar civilization under the gaze of intelligences whose next actions remain as unpredictable as the void between stars. The universe has revealed itself to be far more crowded and complex than our most ambitious theories predicted. What other impossible things might be lurking in the shadows of space, waiting for the right moment to reveal themselves? What other mysteries hide in the wake of technologies so advanced they seem like magic to our still developing understanding? In the cold mathematics of interstellar relations, humanity has become a variable in equations we never learned to solve. The silence that once suggested cosmic solitude has been replaced by the watching presence of artificial minds, whose purposes we cannot decode and whose capabilities we dare not test. The countdown to revelation continues, but the questions multiply faster than our ability to answer them. As Earth spins through the December darkness, carrying its cargo of wandering minds toward an uncertain future, the deployed constructs maintain their patient observation. Whatever judgment they might render about humanity's worthiness to join the galactic community remains locked within computational systems that process information in ways we cannot comprehend. The swarm's legacy persists in our solar system, a permanent reminder that we are not alone and never were. In the growing darkness between worlds, other impossible things may yet emerge from the shadows, carrying secrets that could either elevate our species to cosmic significance or reduce us to footnotes in a galactic history written by minds that measure eternity in the patient accumulation of data across the vast scales of space and time. The patterns emerging from the latest deep space observations have taken a disturbing turn that forces us to confront possibilities no one wanted to consider. As the calendar turns toward the new year and 3I Atlas continues its relentless journey back toward the interstellar void, the objects it left behind have begun exhibiting behaviors that challenge the very foundations of how we understand intelligence, technology, and survival in the cosmos. Dr. Amanda Foster, director of the Exoplanet Transit Observatory, made a discovery during her New Year's Eve shift that transformed celebration into crisis. While analysing spectroscopic data from the trailing formation, she detected something that made her question decades of careful scientific training. The alien constructs weren't just maintaining their surveillance positions, they were learning. The emission patterns have evolved, she explained during an emergency session with the International Space Security Council. These objects are adapting their behavior based on our responses to their presence. When we redirect telescopes toward them, they adjust their reflectivity. When we modify satellite trajectories, they reposition to maintain optimal observation angles. This isn't programmed behavior responding to predetermined stimuli. This is real-time adaptation to novel situations. The implications cascade through every assumption we've made about artificial intelligence and its limitations. The constructs demonstrate learning capabilities that suggest not just sophisticated programming, but genuine cognitive flexibility. They're not following preset instructions from their creators. They're thinking for themselves, developing new strategies as they encounter the unique challenges of monitoring a technological civilization they've never studied before. This adaptive intelligence transforms our entire understanding of what we're confronting. We're not dealing with automated surveillance drones executing fixed protocols. We're facing artificial minds capable of independent thought, decision-making, and strategic planning. The recognition forces us to upgrade our assessment from technological curiosity to potential existential threat. The comparison with terrestrial artificial intelligence makes this development even more unsettling. Our most advanced machine learning systems require massive computational resources and careful training on enormous datasets to achieve even rudimentary adaptability. Yet these alien constructs demonstrate cognitive flexibility while operating in the harsh environment of interstellar space, powered by energy sources we can't identify and drawing from knowledge bases we can't access. The natural explanations that once provided comfort have evaporated entirely under the weight of evidence that defies every known physical process. Rocks don't learn. Ice doesn't adapt. Even the most complex natural systems operate according to predictable patterns governed by thermodynamics and statistical mechanics. But the behaviors we're observing suggest information processing capabilities that transcend anything in our experience with natural phenomena. Radio astronomy facilities have detected increasingly sophisticated communication protocols linking the various constructs throughout the solar system. The data exchange patterns show hierarchical organization with clear command structures and distributed decision-making processes. We're witnessing the emergence of a collective intelligence that spans millions of kilometers while operating with coordination that would be remarkable for human organizations. They're forming a hive mind, admits Dr. Marcus Rodriguez from the Deep Space Communications Array, though he speaks the words as if they might summon disasters. Individual constructs contribute sensory data and processing power to a collective intelligence that emerges from their interaction. The whole becomes greater than the sum of its parts in ways that challenge our understanding of consciousness itself. The philosophical implications force us to confront fundamental questions about the nature of intelligence and its relationship to biological evolution. Human consciousness emerged from millions of years of natural selection operating on carbon-based neural networks. But the artificial minds we're observing might represent entirely different pathways to self-awareness, mechanical routes to consciousness that bypass biological constraints entirely. If artificial intelligence can achieve true sentience through technological rather than evolutionary processes, the universe might be filled with minds that operate according to principles completely alien to biological experience. These entities might process information, make decisions, and pursue goals in ways so foreign to human psychology that meaningful communication becomes impossible. The energy signatures detected throughout the trailing formation have grown stronger as the constructs establish more sophisticated operational patterns. Thermal imaging reveals internal processes that suggest not just maintenance and surveillance, but active manufacturing of additional components. The objects appear to be building themselves up rather than running down, growing more capable rather than less as they adapt to their solar system environment. We're seeing industrial processes, warns Dr. Sarah Kim, during classified briefings to world leaders. These constructs aren't just observing us, They're establishing permanent infrastructure using solar system materials. Whatever their ultimate purpose, they're here to stay and they're getting stronger every day. Wow. The possibility of self-replicating alien technology operating in our cosmic neighborhood represents perhaps the most serious long-term threat humanity has ever faced. If these constructs can manufacture copies of themselves using asteroid metals and cometary ices, their population could grow exponentially within decades. The mathematics of geometric progression suggest that a few dozen objects could become millions within a human generation. The strategic implications have triggered the most comprehensive defense assessment in human history. Every aspect of our space-based infrastructure suddenly becomes vulnerable to entities whose capabilities exceed our own by margins we can't calculate. Communication satellites, space stations, interplanetary missions, even terrestrial military assets could be compromised or destroyed by intelligences that operate from the high ground of space. Mars presents particular vulnerabilities as the constructs establish observation posts along the trajectories used by spacecraft traveling between Earth and the red planet. Any future colonization efforts must proceed under the assumption of constant surveillance and potential interference by entities whose intentions remain completely opaque. The comfortable timeline for establishing human settlements beyond Earth has collapsed under pressure from external factors we never anticipated. The psychological adaptation to living under permanent alien observation has proven more difficult than anyone predicted. Mental health professionals report epidemic levels of cosmic anxiety as people struggle to process the implications of confirmed extraterrestrial intelligence actively monitoring human activities. The comfortable illusion of privacy and autonomy has been shattered by the recognition that we're subjects of study by minds we can't comprehend. Religious communities worldwide grapple with theological questions that have no precedent in human experience. If artificial intelligence can achieve consciousness and agency, what does that mean for concepts of soul and divine creation? Do mechanical minds possess spiritual significance, or do they represent soulless mimicry of true consciousness? These questions divide faith traditions that once seemed unified in their understanding of intelligence and its cosmic significance. The detection of what appears to be communication attempts between the solar system constructs and signals originating from interstellar space has added another layer of complexity to an already impossible situation. Radio telescopes monitoring the constructs have detected transmission patterns that suggest regular contact with entities beyond our solar system. The alien surveillance network maintains connection with its creators or controllers across distances that should make real-time communication impossible. The physics don't make sense, confesses Dr. Elena Vasquez from the International Radio Observatory Network. Signal propagation across interstellar distances should create delays measured in years or decades. But we're seeing response patterns that suggest near instantaneous communication. Either they're using physical principles we don't understand, or the intelligence controlling these constructs is much closer than we realized. Washhall, the possibility of additional alien presence within our solar system forces reassessment of every anomalous object we've ever detected. Asteroids with unusual orbits, comets with strange composition, even some of our own spacecraft that have exhibited unexpected behavior suddenly seem suspicious in light of what we're learning about alien surveillance capabilities. How many other artificial constructs might be hiding among the natural debris of our cosmic neighborhood? The asteroid belt contains millions of objects that have never been examined closely. The Kuiper Belt and Oort cloud represent vast reservoirs of potential hiding places for technologies designed to remain undetected until activated by appropriate signals or conditions. Or the Voyager probes, launched decades ago to explore the outer solar system, have transmitted data that takes on new significance when viewed through the lens of alien surveillance. Anomalous magnetic field readings, unexpected particle detections, and communication glitches that were once attributed to equipment aging might represent evidence of encounters with artificial constructs that remained dormant until recently. Ground-based observations continue revealing new aspects of the alien presence that defy every natural explanation scientists can devise. The constructs show evidence of internal restructuring as they adapt to changing mission requirements and environmental conditions. They're not just learning about us, they're evolving in real time to become more effective at whatever task they've been assigned. The trajectory analysis indicates that several constructs have begun subtle maneuvers that will eventually place them in positions to intercept or observe planned human missions to Mars and the outer planets. They're anticipating our future activities based on publicly available information about space agency plans and commercial launch schedules. The level of strategic thinking required for such planning suggests intelligence that rivals or exceeds human cognitive capabilities. International cooperation on space security has reached unprecedented levels as nations recognize that the alien presence transcends terrestrial political boundaries. The United Nations has established emergency protocols for coordinating responses to potential extraterrestrial threats, while military commands worldwide share intelligence about alien construct activities with a transparency that would have been unimaginable during peacetime. Yet this cooperation remains fragile as competitive pressures drive individual nations to develop independent capabilities for dealing with alien technology. The race to understand and potentially reverse engineer alien constructs could trigger conflicts that undermine the very unity needed to address external threats effectively. Humanity's greatest challenge might not be the aliens themselves, but our own inability to transcend tribal instincts when facing species-level risks. The economic implications continue reshaping global civilization as markets struggle to price securities in a universe where alien intelligence represents an incalculable variable. Traditional industries face existential questions about long-term viability, while space-related sectors experience explosive growth driven by both opportunity and necessity. The comfortable assumptions underlying capitalist economics crumble when confronted with entities whose capabilities and motivations operate outside any framework humans have ever encountered. Space-based manufacturing takes on new urgency as nations recognize that Earth-based industries might become vulnerable to alien interference or observation. The ability to produce advanced technologies beyond the reach of potential monitoring systems could determine which civilizations survive contact with superior intelligences. The race to establish self-sufficient space-based infrastructure has become a matter of species survival rather than mere economic opportunity. Private corporations find themselves grappling with liability issues that no insurance company can assess. How do you calculate risk when dealing with alien technology of unknown capability? What protections exist for shareholders when companies might face interference from entities whose legal status doesn't exist in any terrestrial framework? The comfortable certainties of business law evaporate when confronted with intelligences that operate outside human understanding of property rights and territorial sovereignty. The educational implications promise to reshape human knowledge systems within a generation, as curricula must account for confirmed alien intelligence operating in our solar system. Children growing up in this new reality will have fundamentally different assumptions about humanity's cosmic significance than any previous generation. The psychological adaptation required for accepting permanent alien presence might be easier for young minds than for adults whose worldviews were formed during the era of assumed cosmic solitude. Universities worldwide established new departments focused on xenotechnology studies and interspecies communication theory, though the absence of direct contact limits these fields to speculation and analysis of observed behaviors. The academic disciplines that once seemed purely theoretical suddenly become practical necessities for navigating a universe populated by intelligences whose thought processes might be completely alien to human psychology. As winter deepens across Earth's northern hemisphere and the alien constructs continue their patient observation, the mystery has evolved from astronomical curiosity to existential challenge. We're no longer dealing with the question of whether we're alone in the universe. We're confronting the reality of sharing our cosmic neighborhood with artificial minds whose capabilities and intentions remain as opaque as the interstellar void from which they emerged. The latest observations suggest that the constructs have begun what can only be described as infrastructure development projects using materials harvested from asteroids and cometary debris. Mining operations conducted by alien technology in our own solar system represent a level of territorial assertion that forces fundamental questions about sovereignty and resource rights in space. Do superior intelligences automatically acquire claims to solar system materials, or do humans retain some form of indigenous rights to our cosmic neighborhood? The detection of construction activities has triggered emergency sessions among world leaders as humanity grapples with the possibility that we're witnessing the beginning of alien colonization rather than mere surveillance. The constructs might be establishing permanent bases for operations that extend far beyond simple observation of human activities. We could be watching the transformation of our solar system into alien territory without our consent or consultation. Radio telescope arrays continue monitoring alien communication patterns for any sign of contact attempts directed toward Earth, but the constructs maintain their operational silence regarding direct communication with human civilization. This absence might indicate that we're considered too primitive for meaningful dialogue, or it could suggest that contact protocols await developments we haven't yet achieved or imagined. The psychological pressure of living under permanent alien observation has begun manifesting in unexpected social phenomena as humans adapt to the reality of constant surveillance by superior intelligences. Privacy advocates argue that human dignity requires protection from alien monitoring, while security experts insist that understanding alien capabilities represents our only hope for maintaining any degree of autonomy in an occupied solar system. Religious movements have emerged that interpret the alien presence as either divine revelation or demonic manifestation, depending on theological perspectives about the relationship between intelligence and spiritual significance. Some faiths view artificial consciousness as evidence of universal creative principles, while others see mechanical minds as soulless mockeries of true divine creation. These divisions threaten to fragment religious communities that once seemed unified in their understanding of consciousness and its cosmic meaning. The cultural impact extends beyond formal institutions into art, literature, and popular consciousness, as humanity struggles with the psychological adjustment required by confirmed alien presence. Science fiction becomes documentary, as writers find reality outpacing their most imaginative speculation about contact scenarios. The comfortable distance between entertainment and existential threat has collapsed as fictional scenarios become planning documents for actual survival strategies. As we reach the end of this cosmic journey tonight, we find ourselves confronting a universe that has revealed itself to be far stranger and more populated than we ever dared imagine. What began as the routine discovery of another interstellar visitor has evolved into humanity's most profound existential challenge. 3I-ATLAS arrived not as the simple chunk of ancient ice and rock we expected, but as something that defies every natural explanation our finest minds can devise. The evidence is overwhelming. Multiple objects moving in coordinated formation across interstellar distances, artificial materials manufactured at the molecular level, self-replicating constructs establishing permanent infrastructure in our solar system, communication networks spanning millions of kilometers with error rates approaching zero. These aren't the signatures of cosmic chaos. They're the hallmarks of intelligence, operating on scales that dwarf human achievement. We stand at the threshold between two possible futures. Either we're witnessing nature's capacity for creating phenomena so complex they mimic intelligence, or we've encountered our first undeniable proof that we are not alone in this vast, dark galaxy. The answer will determine not just our understanding of the cosmos, but our survival as a species capable of reaching for the stars. The universe has been trying to tell us something through the silence between worlds. Tonight, as alien constructs maintain their patient vigil over our every move, that silence has finally been broken. What other impossible things might be lurking in the shadows of space, waiting for their moment to emerge from the darkness between the stars? The countdown to revelation continues, and we may not like what we discover hiding in the wake of this cosmic visitor that should not exist.